Inversion.
Hi, welcome to readmeproject.com. Let us see the process of new channel selection tool for JPEG Steganography. Here is the abstract of our process. Here, steganography is the art of hiding information in image. To improve security of JPEG steganography, two approaches are used: matrix embedding and channel selection. Matrix embedding, less modification are needed to the image. In channel selection rule, here it is used to find the DCT coefficient for embedding the secret bits. In channel selection, consider three factors: production error, quantization step, and magnitude of DCT coefficients. So to find these coefficients, first the images are split into equal sized blocks. After splitting the images, the DCT calculations are done by using these factors. Based on the channel selection rule is applied based on the modified matrix encoding algorithm. After finding these coefficients, here more than one embedding changes are applied in each and every coefficient block. So more than one secret bit is embedded into that image. Finally, obtain the image is called stego image. Finally, we conclude that there is no difference between the cover image and stego image, so that we provide high security in JPEG steganography. Here is the DFT of our process. First, we select the image. The input image is called as cover image. Then moves to split the image. Here, the input image is splitted into equal size blocks, that is 8x8 pixel size. Then moves to find DCT coefficient. Here, the DCT coefficient is applied for all splitted images. Then moves to quantization step. Here, using the quantization step, we have to get the magnitude of quantized DCT coefficient. In our channel selection rule, based on the coefficient's value, the channel is selected for hiding the data into that image. So, for hiding the data, we have to select the secret message. The secret message is converted into secret message bits using modified matrix encoding algorithm. Based on this algorithm, the encoding is done. And the decoding process, we have to retrieve the original file embedded in that images. In our performance evaluation, we have concluded that there is no difference between the cover image and stego image. Stego image means the embedded image. So we have to achieve high security performance compared to this our previous approaches using our algorithm, magnitude of quantity DCT coefficient, and modified matrix encoding algorithm. Here is the demo of our process. Here, select the input image. The input image size is 512 into 512 image. Then moves to next process. Here the image is going to be splitted. So the images are splitted and the images, all splitted images are stored in current directory. Then moves to process. Here by clicking the process button, here the input images, all splitted images are retrieved from the directory and displayed. Here the sample 64 images are displayed. The all 4096 splitted images are stored in current directory. Then go apply DCT coefficients to that all splitted image. So the image size is 512 into 512. By clicking apply DCT coefficient, the DCT coefficients are calculated for that images. So the DCT is successfully calculated. Then moves to next process. Here the DCT values are calculated before data hiding process. So the DCT values are calculated. Then the DCT values are quantized. So that quantized DCT values are also finded. Then moves to next process. Here selected the any one of the images and apply the DCT coefficient and show the DCT coefficient and quantized DCT coefficient of that selected image. Here is the splitted images of the original image. Here select any one of the image, apply DCT coefficient images. Here the selected image is image 5. The DCT coefficient is applied. So the DCT coefficient values are shown and the quantized DCT coefficient values shown. So here the quantized values are shown. Then moves to next process. Here the selected cover image is hide by MP. Here you have to select the secret message for hiding the data into that image. Select any one of the text file. Here we have to select the file server text file. Here the secret bits generation. Using our MME algorithm, the secret bits are generated based on the MME algorithm. Then moves to next process. Here select the cover image. Here is our secret message. So embedding process means this text file is embedded into that image. So by clicking embody process, the image was encoded using MME algorithm and you have to save any one of the location. Here give any one of the name to save the encoded image. Here I give the encode. Image encoded and saved. Then moves to next process. Here select by clicking select cover image means the original image is selected. Here by clicking select Stego image means our embedded image is selected. Here we find out there is no difference between the original image and Stego image. Then moves to next process. Here the accuracy rate calculation for that Stego images. Here training data. Here the training data created successfully and testing data. Here the training and testing process, we have to select the half of the image for training process and remaining half of the image of the testing process, and then calculate the accuracy rate of that selected images. So the accuracy rate here we have to give the lambda values as 0.5, 0.5, 0.5, 0.2. Then the accuracy rate is calculated based on the all other lambda values. So that move to the next process. Here we have to show the graph for our accuracy rate calculation. Here the QS and MQ graph separately. It shows performance evaluation for QS and MQ separately. QS means quantization step and MQ means magnitude of quantization step. Here the accuracy rate is calculated for that image with different parameters value. The first one is 0.5 and 0.2 and 0.5, 0 and 0, 0.5 and 0, 0, 0.5, 0.5 and 0, 0.2. Here, the accuracy rate is most low for the parameters 0.5 and 0.5 and 0, 0.2 because that is low means that detectable distortion of that Stego image is very low. So thereby we achieve high security of that image. So we denote that our accuracy rate is low for that 0.5 and 0.5 and 0, 0.5. So there is our Stego image is very minimum detectable distortion, but so that we have achieved high security. So compared to other lambda values, the detectable distortion is very low for that 0.5 and 0.2, so that it provides very much security. Then moves to the QS and MQ separate and combined. This graph is also denoted for performance evaluation for quantization term and magnitude of quantity situation combined process. Here it's also denoted for the accuracy rate calculation. The accuracy rate is very low for 0.5 and 0.4. It also denotes that high much security for our JPEG Steganography compared to other one. So there is no difference between cover image and Stego image, and the detectable distortion of that Stego image is very low. Here is the very security achieved in JPEG Steganography. Thank you.